even though I'm leaving at 1-ish, after makeup tests are hopefully done and we can all have an amazing weekend, although I have a lot of things to catch up on before accreditation next week. Anyway, you could still technically slide it under my door because there's about a 1-inch gap and anything can slide under. And the janitor maintenance people know, even church people know that if something gets put under my door, that they put it on the table and I catch up with it when I come back. So technically, I guess you have until the hallway is locked tonight, which will probably be around 7.
How many lessons are in chapter 7?
Good question. I think there's like 6. An airplane flying into a headwind travels the 2,000 mile. Okay, you guys have already read it. I don't need to read it again, right? My question is, have you found the 2 unknowns yet? If there were 3 unknowns, we'd be looking for 3 equations. We're really hoping there's only 2 because that's the only types of systems we've been seeing thus far. What's one unknown? Speed of what?
Wind.
Okay, speed of the wind. We'll call him y. What else are we missing? Airspeed of the plane. We'll call that x. Because that's what we're supposed to find. So if we're needing to find it, that's always a good clue word, right? Be a detective. That's always a good clue word. Then I must not know that. Okay, x, and I must not know that. Okay, y. Now I go backwards from the question or backwards from the problem that I'm supposed to be figuring out to look at the information I've been given. So, have we been able to find 2 conditions? 2 conditions, 2 facts, 2 statements that I might be able to use. What do you guys see? There's like 3 different numbers. No one's even said one of them. Is how far? Right? Massachusetts, East Coast. Salt Lake City, Utah, over here in the west. Whatever, I just drew a line. Yeah?
Yeah.
Okay, 2,000. That's how far I'm flying both from Massachusetts to Salt Lake City. And we're assuming it's the same flight path back. We're not actually doing the crazy, like how you go up and then over and down. And then we'll just say, okay, we're flying that, just to make it simple. It's already hard enough without making that more difficult. So 2,000 here, 2,000 back. What else do I know? On the way here. 4 hours and 4 hours and 24 minutes. I know that's nice as far as like actual real life, knowing how long it is. But in math, don't we usually want it all in 1 unit? Degree. We're talking about time. Oh, that's true. Minutes and seconds are like a way of splitting 1 degree into a very smaller degree, but that's also talking about degrees and angles, which is very different than time. Good old-fashioned time. What do you guys want to do? Make it a 4-point hour or make it a something minute? Okay, so we have 4 times 60 is 240 plus 24 is 264 minutes. So it took 264 minutes on the way here, and it took only 240 minutes on the way back. If it was the exact same flight path, my question is, what made the difference? Wind. So did you guys catch that there was another clue? Flying into a headwind, and on the return, well, we're kind of assuming a lot, I know, but we're assuming that there was a headwind going this way, and that means it was going with the wind this way. Does it make sense that if your or a plane is traveling with the wind, it'll go faster than when it's battling against the wind? Okay, so that's why this one's longer, and that's why this one's shorter, and that's why sometimes maybe you can get into a place earlier than the ticket actually says. So, aren't I supposed to be finding like equations or something? They're saying that the wind is working directly opposite, or the wind is working directly with. Guys, vector addition. If I have, chapter 6. If I have one going this way and one going that way, but they're perfectly in line with each other, can't I say just the magnitude of x minus the magnitude of y? If the wind is directly against, which is very rare, usually you have some sort of wind coming from the southeast, northwest, northeast, southeast, whatever. Southwest, whatever I didn't say. But this one is just trying to make it easy and say headwind, you're directly heading into the wind, aka the wind is completely opposite you. So as the wind blows and you push, it's going to slow you down by the same amount that it's blowing. So I could say x minus y, airspeed of the plane minus the wind, is going to equal that. Wait a minute. What is speed measured in? Yeah, if you're thinking like on your speedometer, isn't it miles per hour in a car? But wait, this one's not miles. What are they giving us? Oh, it is miles. It is miles, but it's miles per minute. Okay, well, if it's miles per minute, how do I take my 2,000 miles and my 264 minutes and get like an actual rate to compare this to? Think chemistry. If you want miles per minute, you have miles and you have minutes. What can you do? Yeah, kind of dimensional analysis. Can't you just build a bridge and say, hey, I went 2,000 miles? Now, this one's a little bit different because technically we're not getting rid of anything. We're trying to make it match, but we're using the same idea. We're not multiplying and crossing out, but I made a bridge to say, hey, 2,000 miles in 264 minutes. I'm trying to get my miles per minute. I can't. Or there is a good old school distance formula that says distance equals rate times time, which means that rate equals change in distance over change in time.
Oh.
We could have done that one. That's physical science, I think. Ends up being the same.
Yeah.
So I'm just saying you could think of a bridge or you could think of like an actual physics formula. But that's on the way there. And I'm missing an x and a y. Oh, that's why it's in the systems section because I need two equations. Well, I don't just know about the way there. I also know about the way back. So can't I now say that the wind is working with the plane because it's going faster now? I'm still talking about miles per minute, which means I still need to build a bridge, which in this case, I'm still going 2,000 miles, but what's changed on this part? Yeah, I'm doing 240 minutes. Now, some of you right now might be like, I wish we had done hours instead of minutes because miles per hour makes more sense, but either way. If we have miles per minute, can't we always actually build the bridge to get rid of what we don't have? So we can always change it later if we need to. Oh, because traveling into the headwind means that, who's quick and easy? Izzy, come here. Okay, Izzy's the wind and I'm the plane. Yeah. Ready? Now, you can't push very hard because the wind theoretically isn't as strong as the plane. Just a little bit. Ready? Just hand. Ready? Okay, if I'm trying to push, I'm the plane, and she's pushing against me. We're pushing directly against each other, which means my desired force is being subtracted by her countering force. Does that make sense? So, if I'm flying into the headwind, the wind is slowing me down. True? But then, oh, Izzy, just stay seated. It's okay, just got up. We're ready? Just push my hand. Push with, no, Izzy. Ella would be my headwind, right? Because we would be countering, but then Izzy, and then push with me. Right? Now we're adding as opposed to subtracting. Does that make sense? Okay. So if I'm flying into the wind, if I'm running into the wind, come on, my runners, if the wind is right against you, is that fun?
No.
No, if you're swimming against the current. If you're, right? Like, if you're walking up the down escalator, like, it's going to subtract how fast you go.
I love walking.
But if you're walking up the up escalator, oh, man. Or those little, like, walkways in the airport, you're going, like, the right direction, like speed right along. So that's the idea of the subtracting into the wind is against me, or with the wind is for me. Ooh, for or against me, that's a Bible verse. Anyway, so then, we need to go ahead and solve, but right now these numbers are disgusting, but technically, I mean, I don't mind disgusting numbers. I have this thing called a calculator. Can't I just add down and do elimination? Oh my goodness, that's the section that we're in. And we end up with 2,000 all over 264 plus, because I just added down so that my y's canceled, 2,000 all over 240. Different denominators, so I cannot just combine like fractions, but that's all right. I'm a big girl. I can go to my calculator eventually. So I'm going to go ahead and have my 2,000 over... Is it out of Staples? Is that what's on?
No, I got you.
Oh, okay. Thanks for fixing it. I appreciate it. 2,000 all over 240. Once I add those two fractions, what do I need to do? Divide by 2. Got them. And I end up with, ew, gross, why is mine in fraction mode? Have you guys noticed whenever you put in that cool fraction, it only does fractions and not decimals? It's kind of like a little bit of a tedious, like, oh, that's annoying. But you can always go to math and then go to fraction or go to decimal and make your fraction into a decimal. Either way, I end up with x is equal to 7.955 miles per minute. Oh man, that's a slow plane. X was the plane.
You gotta multiply by it.
Yeah, it's per minute. I mean, is anything that I have moving 7 miles per minute? No, that's per hour. That's what we're much more used to. So get those 60 minutes per 1 hour. If you didn't want hours before, you should go to them eventually, because 7.955 doesn't really match up with anything any instruments would show. But if I go to miles per hour, I think I might have a bit better measurement of what's going on. 477.3 sounds a little bit better. Miles per hour. Oh my goodness, just do MPH, right? If that's how fast the plane is, all you need to do to figure out how fast the wind is take that 47.3 and come back up and say, okay, let's solve. Oh, struggle though. Will it work out well if I bring the 477.3 and plug it in right now? No, because I'm talking about miles per minute, so if I could bring that 7.955 up, get the wind, and then convert. So I'm going to go ahead and take my 2,000 divided by 240. I'm just doing division because I don't like that whole go to a decimal thing. I'm going to subtract that 7.995. Ooh, I'm going to subtract a big decimal, less error. I'm going to get my y to be 0.379. And that's miles per minute, so I just need to go ahead and multiply by my 60 minutes per 1 hour. And then I can go ahead and have my miles per hour, which would be 22.7. Were there two unknowns? Yes. For me to solve it, did I need to make two equations? Yes. Was it a system? Yes. Did there need to be at least a little bit of fundamental knowledge to be able to do this problem? Yeah, you had dimensional analysis in here. You had some distance equals rate times time and making units match and trying to think about the information that you were given going into the wind versus being helped by the wind. But anyway, long story short, things can get interesting. Section 7.2, due on Monday. Now, kiddos that were gone yesterday, we kind of talked about homework, but not to its full extent. Alec was mentioning, no, we did. We talked about the word problems numbers 60 and 62 and something else. But I think Alec had another question, and I also wanted to allow those of you guys that were gone yesterday to ask questions as well. And I don't think we officially graded the evens. So I'm opening up a lot of things right now. I'm opening up the evens from 7.1, substitution. I had a question at the end of yesterday about what the test might ask as far as, is it going to force us to do substitution if elimination is easier? It's possible in a multiple choice that a question could say use substitution or use elimination or use row echelon form. Uh-oh, that's something new that's coming. We didn't officially grade our evens, so you guys are grabbing at your colored pens, but also if you got stuck somewhere else beyond what we talked about yesterday, and if you didn't know, that's okay, still ask your questions, and I'll let you know either like, hey, it's in the video, or hey, yeah, let's go over it. I know, Alec, you had that one extra one you wanted to ask, but someone else might have a question too. But for the test, it might say use substitution or use elimination. Pretty much, if it's on the test, and if I've said use something specific, I just want to make sure you know how. It's not necessarily that I'm going to make the entire test, I'm going to make you do it the hard way. That's not necessarily, like, for most of the test, you can choose which way you solve your systems, but there might be a question here or there that gives you a use this method because I want to make sure you know the method. So anyway, all that to say, could you have done elimination in some of 7.1? Yeah, like it's not a big deal. I understand. Some of them were easier with elimination, but just make sure you know how to do substitution. And vice versa in section 7.2. There might be some that are easier to do a different way. But just make sure you know how to use elimination. So number 4, the first answer was break even. Number 6, we end up with, we're doing an ABCD with yes or no, true or false. We have a yes, no, no, yes. It worked, it didn't, and then finally in D, it did again. Ooh, it's a fraction. Those common denominators make a difference. Number 10. You did not have to write out all this work, but at the end of the day, you should have gotten that x equals 0 and plus or minus positive, negative, square root of 3. So then you would have had to take each of those and go find their corresponding y values, and none of them were extraneous. All of them worked just fine because the domain of these guys were all real numbers. Number 26, I think, Priyanka, this was your question, right?
Yeah.
Number 26 was one where we were given a table. We talked about it in detail yesterday, so if you missed yesterday, no big deal. Check out the video when we were talking about how the two unknowns were how much money you put in one account and then the other account. That was X and Y. And the two conditions were you knew the total amount was $12,000 and you knew the total interest was $630, making two separate expressions for the two conditions that were there and present in the problem. Final answer was 4,500 at 4%. That was X in my problem. And 7,500 at 6%. But you guys could have called the 6% X and the 4% Y. So we're just saying, okay, 4,500 went with the 4%. 7,500 with the 6%. Number 44 was a little weird if you guys had tried to solve by hand. Oh, no, that was a different one.
You had to graph it.
Yeah, this was the one where they actually wanted you to graph. And as you graph, I mean, you can graph a circle with a radius of 5 fairly quickly. And a circle with a radius of, root 41 that's centered at HK 80. You had to go over 8 at 0 and then go with square root of 41. I'm not entirely positive that just drawing the graph would have perfectly given me beyond a shadow of the doubt what the intersections were. I think it would have just shown me that there were intersections. Because square root of 41, I mean, come on, really, we're going to graph that perfectly? No. But we could know that it's something between 6 and 7 and estimate. So, I don't know, there was a question yesterday, if it says to solve graphically, you could have gone to your graphing calculator. We talked about yesterday, check out the video. How to get y by itself, the positive, negative square roots. But at the end of the day, to be totally honest, I think it would have been so much easier just to subtract, get rid of the y squared's FOIL, and then just factor. I don't know. That's me. But if you really want to go plus or minus square root and then find the intersections for 2 different circles, so 4 different y1, y2, y3, y4, that just sounds tedious. Number 60 we talked about yesterday. Someone had a question on 60 and 62. So if you guys have questions on those 2 word problems, the video yesterday is where you want to go. And number 62, the warning was, once again, I don't know. I think it would have been tedious trying to get this window randomly where the y's don't zoom out at all and the x's zoom out tons. Because your zoom out feature zooms out everything, and it might have been hard to find this intersection. I think I would have just maybe solved for x squared and then plugged in, and I don't know, maybe I wouldn't have. Off the top of my head, that window could be hard for some of you to find. To be honest, I probably would have just played with my calculator because I would have seen what was going on. But I understand if you're like, I could not get that window, then maybe just solve for x squared and FOIL it out and plug it in. But I told you which ones are on the video yesterday. You guys have had a chance today to make sure you have all the answers matched. Is there anything else? I don't know, Alec, if you still have that question or if there's anything else that wasn't covered or isn't on the video that you guys want to ask about.
I think it was 31.
31. Anything else besides 31 that you guys can think of? No? If you guys started homework last night, you can also be looking and seeing if you got stuck anywhere. If you got stuck anywhere, now's a good time. I can quickly pop over to section 7.2, and if we can cover it for everyone's sake for this weekend, sweet. Anything else on this homework? Yeah. So number 31. And here's the bummer in that it says to solve the substitution. I think I would have wanted to do elimination. But if you guys were good and followed the directions, then in that case you would have gotten that x is equal to y minus 1. Which is, I don't know if I like that, but that's okay. All right, fine. Y minus 1 quantity squared minus y equals -4. As long as you square it, not killing a puppy, you have to FOIL. I'm using the perfect square trick of you square and then you double -y and then you square. You would have gotten y squared minus 3y plus 1 plus 4 plus 5 equals 0. 5 and 1 makes 4 or 6. That's not helpful. So I think we need to do our -b plus or minus square root b squared minus 4ac all over 2a. What's true about 9 minus 20? Negative. Square root of a negative? Imaginary. Imaginary means no real solution. Nice, right?
Yeah, that's why I was completely confused. Because I was in the point that I can like
Perfect. You were right. There's no real solutions. Which means these two lines must be, wait a minute.
There's
Yesterday, inconsistent systems with no solutions at all. This is y equals x minus 1, negative x plus 1. There we go. And this one is y equals x squared minus plus 4. What's going on? I have a parabola that's gone up 4. And then I have a line that is up 1. Are they parallel? No. But are they intersecting? Hey, I think solving graphically would have made life a lot easier. Either way. And then, Megan, you were saying number 26. That's one of those even ones. Why are you so complicated? Oh, he's the one that's on the video from yesterday. Yeah, he's the one that's on the video from yesterday. Priyanka had a question about him too. So check out, I walked through it then. Priyanka. 50. All right, my people that did or started 7.2, get it out. See if you got a second. So you got a little bit of extra time. Oh, 53 had E's and LN's. That's so mean. It's okay, it's not algebra 2. Of course they would bring in extra stuff that we've learned this year. Okay. Priyanka, why am I subtracting? Make my life a little bit easier. I always think through subtracting as adding the opposite because I want to make sure before I get in the midst of craziness that I know the signs properly, so I just distribute. But yeah, my y's go away. I end up with an ln of x, just because I like the positive guy first, minus e to the negative x equals negative 3 plus 1 is negative 2. If we were supposed to solve this by hand, it would be a bit of a party. I just have the book right back here, so I'm making sure it says graphically or algebraically. I'm guessing that means that the fellows we need in like 2 seconds, otherwise we wouldn't be backing up. Better be 2 seconds. My advice, I think, Priyanka, would technically be, if it said graphically, you could do y1, y2. In some senses, to be honest, we could actually make this a much better distribution in the sense of we could add the e to the negative x and get ln of x, and then we would get e to the negative x minus 2, which would be an e swoop, who was reflected the other way horizontally, and then was shifted down 2. So I could actually have him, let's see, down 1, 2. I could get his graph pretty quickly. And ln, well, that's a good old-fashioned ln that crosses at 1, and that's going to swoop up. And we see that there's an intersection right there. The problem is, what is it? It's going to be some nasty decimals because it's in between 0 and 1. In that case, I mean, I see things like I could do e to both sides, but that's going to get to something I don't know how to solve. I could try to take ln of both sides, but once again, something I don't know how to solve. We're going to have to get to your tablet for the desk. Alright guys, see you later. I'll be here for your 7-2 homework ready attended and questions if you have any for Monday. Nutrition time, you've made it.
You're actually really